So my journey started from here, IIT Delhi. Dr. Sanat Mohanty, he was an associate professor over here, and I was his student. My graduation project was a GPU-based molecular dynamics simulator, India's first. That was in 2011-12, when people were laughing at us for using GPUs. And so far, we have come to a place where Sanat is still my CEO, and we have been working together. We have been doing some amazing job for our life science clients. We have around 50 engineers, and we have filed around 6 patents, specifically around not being able to use, not needing to use GPUs, large language models, and vector databases. And I'll walk you through what we have done to make sure that this is possible. So specifically for this radical approach, what we have done is, we know a dragonfly can hunt for food, it can survive, it can reproduce. Now it doesn't have a data center powering it. What it has though is being able to have very few neurons, a million neurons, and it can survive its entire life. If we not talk about animals and if we talk about humans, then we know that there are children who are 3 years old, they can start talking. But if you ask them to play chess, it will be around 11 years until they can actually start playing chess very well. And what that means is, actually speaking, being able to speak word by word is much more easier than playing chess. But still, computers have learned to play chess faster than being able to predict words. How is that even possible? And the reason behind it is that training data structures, the way it has been done, it hasn't been done efficiently. So for an example, in 2018, so before that, Stockfish was the go-to champion in chess, but Leela Zero, Google DeepMind's Leela Zero, it was a pure neural network. It came back and it defeated Stockfish. Stockfish went back, they redeveloped their search engine with a very small neural layer, and then it has been undefeated since. The reason it happened because it was layered in such ways that they optimized their data structures in such a way that it gave maximum impact. And this is our thesis, and it has been true so far, is scaling without optimizing training data structures is world's first $1 trillion mistake. $1 billion mistake was null pointers, and this is going to be the $1 trillion mistake. A lot of people are going to lose money on it. And specifically, when we look at it, we say that where is the issue? So issue is the tokenizer. Tokenizer is 1/3 of the word, or 2/3 of the word. And what you do is you think about it that there are 150K tokens which you use in English next token prediction model, and it's like a mob of 150,000 people trying to take over the city. Think about the communication overhead it needs, or think about the task inefficiencies that it has to actually take over the city. Now compare that with a very small army where there is a general, there is a soldier, there is a captain, there is a brigadier, and each one of them with maximum efficiency can take over a city, complete the task without any trouble. So this information and communication overload that you go with tokenized next token prediction systems, these overload leads to brutal model sizes and compute cost. So how we solve this particular problem. So this is our patented solution. We talk about int64 everywhere. So int64 is embedding. We were able to compress it 400 times than its original value. And then what you get is one document, that is one int64, one paragraph, that is one int64, one sentence, that is one int64, and each entity is one int64. You can then embed location data, you can embed float data, all of them, they form a huge knowledge graph. And this knowledge graph is then accessed by a graph traversal mechanism and a very small, precise neural network. So again, Rishi is here. We heard about Suktam, we heard about Shrutam, we heard about Param, and we have all heard about Sarvam. So I'm very happy to introduce you to Shunyam. It's a generative model at near zero compute cost. So what we have is, instead of predicting token, it predicts a word. So currently what we have is training methodology for large language models is you have pre-training, supervised fine-tuning, RLHF, RLVR, and all of that takes tens of GPUs to actually do something that is a viable model that goes into market. What we do is, instead of this specific token, we predict the next word using the next int64. We predict every bit of that integer, which forms a single integer that then is identified, and it predicts. So again, this is courtesy to Intel and amazing Sanjay Agara, who helped me set this up on Intel AIPC. These are powerful machines, and you can see loading devices XPU. And basically, it is able to predict word by word without needing a huge amount of compute. And we can run it on Raspberry Pi as well. But specifically, if you think about it, it has been trained on 1432 India-specific article. We have a bio model which has trained on 2000 biology-related, life sciences-related article. And we have another model that is finance, which we have trained on 2,500 articles. Compare that with tiny stories experiment that you may have heard, where it takes around 500 billion tokens for emergence of intelligence to come into these, next token prediction model. This is a million tokens, and in a million tokens, we're able to predict the next word efficiently while giving 100% traceability. But think about, while we are doing it, the model size is 108 million parameters. But specifically think about training compute. We used one A100 GPU for 3 hours. That's $45. 4,000 rupees. Matra 4,000 rupees. That is how much it cost us to train this particular model and get it efficiently coding. So again, most of the organizations that you see, they first train the models and then try to apply them into the practice. We didn't do that. So what we do, as a Pienomial, what we do? So we help our clients who are AstraZeneca, Pfizer, who are Merck, GSKs of the world, to build better medicines and help them to target specific demographics that they need. They can efficiently deliver their drugs. So specifically what we have is scientific literature, clinical trials, regulatory filing, unstructured data, which is extremely difficult to tackle. This is not normal Wikipedia data where you can directly start extracting something and go online. This is extremely difficult data where most of the large language models such as Claude and Anthropic and specifically your OpenAI models, they start failing. So what we have been able to do is we have been able to take our foundational models, take our knowledge graph structure, build this particular knowledge platform where we are able to give our clients actionable intelligence with respect to real-time analysis, scenario modeling, unique clarity and insights. And in the end, the final output is accelerated drug development, eliminating human errors, and informed business decisions. So this is what we work with. So again, we are Pienomial. We are based out of Pune. We haven't received any government funding or support, but instead we got guidance and mentorship of these two amazing gentlemen, Shashi Shekhar sir and Alok Agarwal sir. To big a round of applause to both of them, please. And these guys removed thorns from our path even before we knew that there was a path. So thank you very much. And we're based out of Pune. So if you feel like eating some, khamang bhakar vadi, or if you feel like having spicy misal, please come over to our office. We would be happy to have you and talk technology with you guys. So that is it. Thank you very much.
Right through the day, we kept hearing about inclusive AI in India means right, it should be cheap and it should be a little efficient. And here is a great example.